Welcome back to the deep dive. Okay, so you've probably noticed there's just a ton of chatter out there about conservation terms, right?
Right.
Especially in invasion science.
Oh, absolutely. It's like trying to drink from a fire hose sometimes.
Exactly. So that's what we're doing today. We're going to take that flood of info, boil it down for you.
And get you those key nuggets you really need on this. Because honestly, this isn't just, academics arguing in journals.
Right. It has real consequences.
Huge ones. Getting the terms wrong and feels like conservation, which goes in ecology, policy, economics. Well, it messes things up big time.
How so specifically?
Well, confusing definitions. That can seriously undermine conservation work on the ground, waste millions in funding, even turn public opinion against really necessary projects. It's critical stuff.
Okay. And the core source we're diving into today is this new perspective paper by Oficialdegui and colleagues.
That's the one. And they make a really bold claim, basically trying to cut through all that noise.
Bold how? What's the core argument?
Well, the title kind of says it all, really. Nativeness is a binary concept. Invasiveness and its management are not. They're saying, look, the status of a species, where it originally came from relative to humans, that's simple. Binary. Yes or no.
Okay. Native or non-native? End of story for status.
Exactly. But, and this is the crucial part, everything that comes after that, how we manage it, what we do about it, that's got to be complex, flexible, context-dependent. It can't be binary at all.
Right. So that's our mission for this deep dive then. We need to unpack why they insist on this split. Why does accepting a simple binary status, native or non-native, actually help us make better, more nuanced, more flexible management decisions later on?
Yeah, and for you listening, this really matters directly.
Right.
If we can't even agree on what native means, or worse, if we just fall into the trap of equating native with good and non-native with bad.
Then your laws and your management plans are basically built on shaky ground.
Exactly. Unstable foundations. So the authors want this bedrock conceptual clarity. Get the concept right first. Then you could focus all that necessary complexity where it actually belongs. Assessing the real-world impacts, deciding on the smartest response. Simplifying the origin label lets us properly handle the genuinely complex threat, which isn't binary.
Okay, let's jump right into that complexity. Section 1, the terminological tempest. So the paper points out that nativeness is absolutely fundamental to invasion science, but it's also, maybe surprisingly, a huge source of controversy. Why is something seemingly basic so difficult?
Well, it boils down to people using wildly different yardsticks to measure it. A species might tick the native box using one definition, but be completely ambiguous or even non-native under another. It gets messy fast.
And the authors mentioned Gilroy and colleagues highlighting this back in 2017.
Exactly. They showed just the sheer range of perspectives floating around and how that leads to, well, definitional chaos.
So what are some of these main conflicting ways people try to define native?
Okay, so you've got the geographical take first. This one's all about physical barriers. Think oceans, major mountain ranges. Is the species here because it crossed a natural barrier on its own scheme? Or not?
Pretty straightforward, geographically speaking.
Sort of. But then you've got the ecological definition. This focuses less on just getting there and more on, fitting in. Has the species evolved specific relationships, specific roles within that particular ecosystem over time?
Ah, so it's about integration, not just presence.
Right. And then it gets even more complex because human ideas get layered on top.
Like political borders.
Exactly. There are evolutionary definitions, too, which look for really deep patterns of coexistence, like hundreds of thousands of years. But yeah, the political definitions are often the trickiest. Sometimes native status gets tangled up with human-drawn lines on a map. Is a species non-native if it crosses a state line, even if ecologically it's the same region?
I can see how that causes headaches for, say, managing something that lives across an international border.
Huge headaches. It has massive implications for trade regulation, conservation efforts, everything.
Okay, so with all this disagreement, it's no wonder the field is split. What are the main viewpoints fighting it out right now?
Well, the paper lays out three main camps. First, you've got a pretty radical view. Some argue that the whole concept of species nativeness just doesn't exist anymore. Maybe it's outdated, too culturally loaded, or just impossible to define with climate change shifting everything.
Okay, that's one extreme. What else?
Second, there's the idea that, yes, nativeness exists, but it's not a simple yes-no. It's more like a spectrum, a gradient, a continuum.
And the third?
That's the position of the authors of our source paper. They argue no, conceptually, nativeness is inherently binary. It's a fundamental property.
And it's that second view, the gradient idea, that this paper really pushes back against, right? This idea of nativeness as a scale from 1 to 10.
Exactly. They specifically address that challenge. They reference a proposal from Lemoine and Svenning in 2022, which actually laid out a 10-step nativeness gradient.
10 steps. What did that involve?
It was quite detailed. It wasn't just classifying. It tried to link everything.
Yeah.
So you'd classify an organism based on its arrival history, its origin, and its current environmental impact, all bundled together.
Okay.
And the idea was that each step on this gradient, maybe you call something a new native versus, say, an invasive introduction, would then directly suggest a specific management approach.
I can see the appeal. You know, it sounds kind of intuitive. If something's been here for ages and isn't causing trouble, maybe treat it differently than something that just showed up and is wrecking the place. So why do Oficialdegui and colleagues call this gradient approach misguided?
Because, they argue, it fundamentally muddles two distinct things: the species status and the appropriate management response. Nativeness, in their view, is purely a question of historical biogeography. Did humans bring it here or not? That's the status. It's a factual point about origin.
Simple. Yes or no?
Right. But management, that's inherently complex and depends entirely on context. What should we do about it now, considering its ecological role, its social impact, how far it's spread, all those factors?
I get it. So if you start baking management factors like impact level into the definition of nativeness itself,
You lose that clean, objective starting point. The status definition becomes contaminated by value judgments and current conditions.
you can't track the human footprint consistently anymore.
Precisely. The authors really stress that the power of the binary status lies in its scientific simplicity and objectivity. It gives you that neutral baseline. Then you can apply all the complex graded metrics you need for sensible management. Keep the label simple so the difficult conversation about what to do can happen without getting bogged down in definitional quicksand.
Okay, that tees up section 2 perfectly, the binary core. This is where the authors really define their terms and make the case for nativeness as this intrinsic yes-no property. Let's get those definitions clear.
Right. They're building on established work here. So, nativeness, drawing from Pajek and others from 2004, they define it as the property of a species, or taxon, occurring within its natural distribution range. That's the area where it evolved. And, this is the key part, its presence there is not the result of direct human intervention.
Not human-mediated, got it. So non-native must be the flip side.
Exactly. A species is considered non-native or alien or exotic, those terms are often used interchangeably, in a particular area if its presence is down to human actions, whether that was intentional introduction or just accidental hitchhiking. That follows Essel and colleagues from 2018.
And the authors are really firm on this. The status is intrinsic and binary.
Absolutely firm. It's either evolved locally and dispersed naturally, or humans moved it. They argue there's no halfway house biologically between those two origin stories.
Okay, but I can already hear the pushback. The real world feels much fuzzier than that. What about species with huge ranges? Or species we barely know anything about? Or the fact that climate change is scrambling everything anyway? The paper does acknowledge this observational difficulty, right?
No, definitely. And this is such a crucial distinction they make. They say the confusion, the difficulty, it lies in our ability to observe and describe nativeness accurately, not in the concept itself. The binary truth exists, even if we're struggling to see it clearly right now.
So the uncertainty is practical, not theoretical.
Precisely. They list the practical challenges. Yeah, some species have massive distributions, making it hard to know where the natural edge was. There's a massive lack of basic research on huge numbers of species. And yes, rapid global change is constantly blurring lines.
And this leads to the whole category of cryptogenic species, right? The ones where we genuinely just don't know their native range for sure.
It's exactly.
Yeah.
Cryptogenic species are the poster children for observational uncertainty. A species might be labeled status unknown for decades. But, and this is their key point, scientific progress often resolves these uncertainties.
How so?
Well, think about advances in genetic sequencing, new techniques in historical ecology, analysis of old records. These tools are constantly helping us figure out the origin stories of species that were previously mysteries. The fact that the answer is sometimes hard to find doesn't mean the question itself is invalid or that the answer isn't binary. It just means our homework isn't finished yet.
It's like an archaeological dig. Just
Yeah,
because you haven't found the artifact yet doesn't mean it doesn't have a specific location and age down there.
that's a great analogy.
Yeah.
The difficulty is in our knowledge, our epistemology, not in the fundamental nature of the thing, its ontology.
Okay, that framing makes sense. And it connects to the role of human agency in the definition. Because defining non-native relies on spotting that human footprint. Some critics argue that singles out humans, like we're somehow separate from nature.
Right, the old ontological dualism critique, that it treats humans as outside the rules of biology.
How do the authors tackle that?
They cite work by Cuthbert and others from 2020. The argument isn't that humans are magically separate. It's that the way humans move species around global trade, rapid transport, agriculture, moving thousands of species across barriers that were previously insurmountable for millennia, is functionally unique.
So it's a unique mechanism of dispersal.
Exactly. It's different in scale, speed, and scope from natural dispersal like wind or ocean currents. We have to track it separately because its ecological consequences are so profound and widespread. Humans are biological organisms, yes, but our technological ability to rearrange the planet's biota is a novel evolutionary force. We need a term for that.
We're like a unique geological force. Almost.
Yes, that's one way to think about it. And recognizing that unique mechanism helps clarify the temporal issue, too. This often trips people up. What about species humans introduced, say, 2,000 years ago during Roman times? It's been there forever, practically. Surely that's different from something introduced last year.
Yeah, the gradient approach would definitely treat those differently. Long-established non-natives often get a different label, like archaeophyte.
Right. But the authors of this paper argue, from the strict status perspective, time doesn't change the origin story. It's still non-native because humans brought it. That 2,000-year history is incredibly important for understanding its current ecological role and for deciding management, absolutely. But it doesn't change the fact of its human-mediated arrival.
So setting cutoff dates like 1500 AD or whatever, that's just an arbitrary line we draw for convenience.
It's a human construct, useful perhaps for management discussions, but it doesn't reflect a fundamental biological shift in the species' origin. The origin is fixed. It's ecological integration and impact. That evolves over time, but that's a separate question from the initial binary status.
Okay, so the core message is crystal clear. Keep the fact of arrival, binary status, separate from the consequences of arrival, non-binary role and impact.
That's it. Because if you blur those lines, if you say, well, it's been here 500 years, maybe it's kind of native now, you completely lose the ability to scientifically track the true extent and history of human influence on biodiversity patterns across the globe. That clarity is essential.
Right. Which leads us perfectly into Section 3, the gradient of harm. Here's the pivot. We've established nativeness status as binary. Now, the paper argues invasiveness, the behavior, and impact is fundamentally non-binary.
Exactly. This is the crucial contrast. We move from origin story, binary status, to current performance, non-binary invasiveness. And invasiveness isn't an intrinsic property like origin. It's all about context. It's an evaluation.
And evaluations involve human judgment, right? Social factors, economic factors, not just pure ecology.
Absolutely. Defining invasiveness requires us to make assessments based on specific ecological settings, but also on social norms, economic values, and our perception of what constitutes harm. It has to be defined using metrics that we choose, metrics that are often quantitative and exist on a scale.
What sort of metrics are we talking about?
Things like population abundance, how many are there? Geographical spread, how far has it gotten? And crucially, the magnitude of its impacts, what effects is it having, both ecologically and socioeconomically?
And why do those specific things, abundance, spread, impact, force us into a non-binary management approach? Why can't we just say it's invasive, eradicate it?
Because none of those things are simple yes-no answers. A species isn't just abundant or not abundant. Its population density varies hugely across its range and fluctuates over time. Its spread isn't static, it's a moving front.
And impact seems like the most variable part of all.
Totally. The level of harm, or even benefit sometimes, can differ massively from one place to another, from one year to the next. It depends on the local ecosystem, the climate, other species present, and importantly, how different human communities perceive and value those impacts. An agricultural pest in one region might be a food source in another.
So that inherent variability means management has to be tailored.
It has to be flexible, modulated by local conditions, societal needs, economic realities. You simply cannot apply a one-size-fits-all binary management rule across an entire species-introduced range. It wouldn't work ecologically or politically.
Okay, so instead of a simple label, we need tools to measure that gradient of impact. The paper mentions specific assessment metrics, EICAT and CCAT. Let's unpack those. What is EICAT measuring?
Right. These are really important. Think of them like the IUCN Red List, which classifies extinction risk for native species, but these are designed for the impacts of alien species. EICAT stands for the Environmental Impact Classification for Alien Taxa. Its job is to standardize how we measure the magnitude of negative ecological impacts.
So it's a scale of ecological harm.
Exactly. It uses a structured system with clear criteria to rank impacts all the way from minimal concern, MC, where effects are negligible or undetectable, up to massive, MA.
What does it take to get ranked as massive impact?
MA is reserved for situations where the alien species has caused really fundamental changes, like the irreversible extinction of native species, or a complete restructuring of the community, or large-scale alterations to ecosystem processes like nutrient cycling or fire regimes. It's not just a minor tweak, it's a transformation.
Okay. That scale itself shows the gradient. And then there's SECAT for the other side of the coin.
Yep. SECAT tackles the socioeconomic impacts. And this is where things get even more complex and context-dependent.
Because economic impacts can be positive and negative, right?
Precisely. Think of an introduced fish. Ecologically, it might be devastating, outcompeting native fish, changing the habitat. That's a high negative EICAT score. But maybe that same fish now supports a multi-million-dollar recreational fishing industry, or it's become a crucial, affordable protein source for local communities.
So the SICAT score would reflect both the negative costs, say to native fisheries or infrastructure, but also potentially huge positive economic benefits.
Exactly. That species isn't just bad or good, it's complicated. You can't just make it disappear if people's livelihoods depend on it, even if the ecological harm is severe. This forces really nuanced policy responses, maybe trying to control numbers in sensitive areas, promoting harvest, finding ways to mitigate harm without crashing a local economy. Definitely not a binary eradicate decision.
And the paper also mentions EICAT plus SMARTO. What's that?
That's a newer development, designed to specifically classify documented positive environmental impacts of alien taxa on native biodiversity.
Positive impacts from non-natives, like what?
Well, sometimes an alien species might step in to fulfill an ecological role that was left vacant, perhaps because a native species went extinct. Or it might provide habitat or food for native species in certain contexts. It's controversial, but it acknowledges that the ecological picture isn't always purely negative.
Okay, this really drives home the paper's argument against oversimplification. We often hear that simple conservation message: protect natives, fight non-natives. Why do these authors say that's the real oversimplification we need to overcome?
Because effective conservation is fundamentally about managing threat and risk, not just about purity of origin. They draw an analogy to how we manage native species. We don't pour equal effort into conserving every single native creature, right?
No, we focus on the endangered ones, the threatened ones, using the IUCN Red List.
Exactly. We prioritize based on threat level. The authors argue we need the same sophisticated thinking for non-native species. We should prioritize management efforts based on their assessed risk and impact using tools like IICAT and SACAT, not just on the simple fact that they are non-native.
So some non-natives might be completely benign, low ICAT-SACAT scores, and require zero action.
Right. Benign neglect might be the perfectly appropriate response. Conversely, sometimes a native species can become overabundant or problematic, maybe due to habitat changes or lack of predators, and it might require active management or control.
So the management response needs to be sophisticated enough to say, yes, this is non-native, but low risk, leave it alone. Or, yes, this is native, but currently causing harm, we need to intervene.
That's the core idea. Management needs that flexibility, that context specificity, the focus on actual threat assessment. It's conflating the simple binary origin status with the complex non-binary impact gradient that leads to bad policy, public confusion, and wasted conservation resources. We need the binary label for clear tracking, but the gradient metrics for smart action.
This theoretical framework makes sense, but it really comes alive with the case study the authors use. Section 4, the crayfish crucible in Iberia. This seems like a perfect illustration.
It really is. It hits all the key points beautifully. So for a very long time, the status of freshwater crayfish in the Iberian Peninsula, Spain and Portugal, was considered cryptogenic, uncertain.
Meaning people didn't know for sure which ones, if any, were actually native.
Exactly. And specifically, there was one species, the Italian crayfish, Ostropatomobius holsesianus, that was widely assumed, almost taken for granted, as being native to parts of Iberia.
This is part of the local fauna, people thought. What changed that?
A really important interdisciplinary study came out, Clavero and colleagues, in 2016. They dug deep using historical archives, looking at biogeographical patterns, doing genetic analyses.
And what did they find?
They delivered a definitive and pretty surprising conclusion. There are no native freshwater crayfish species in the entire Iberian Peninsula. Zero. None.
Wow. That's a fundamental shift in understanding. So that one finding instantly clarified the status of all crayfish there.
Instantly, the cryptogenic uncertainty vanished. It confirmed the binary status for every single one of the 10 crayfish species that have been recorded as introduced into Iberia over the centuries. They are all equally non-native, including that Italian species everyone thought belonged there.
The uncertainty was just because we hadn't done the historical detective work yet.
Precisely. Observational uncertainty, not conceptual ambiguity. Once the history was clear, the status snapped into focus. Non-native.
Okay, now let's see how this creates the non-binary management challenges. Starting with that Italian crayfish, A. fulcianus, it's non-native, but it's been there a long time.
A very long time. Introduced around 1588, nearly 500 years ago. But here's the twist. Its populations crashed dramatically in the 1970s, likely due to crayfish plague brought in by other introductions. And after that crash, guess what? Spain actually started managing it as a high-priority conservation species.
Wait, conserving a non-native species?
Yep, giving it protected status, trying to help its populations recover. Think about that paradox. A confirmed non-native species receiving national conservation efforts.
That completely blows up the simple idea that non-native always equals bad or eradicate.
Absolutely. The authors suggest we could even reframe this introduction now, looking back, as a kind of unintended conservation introduction. Why? Because A. fulcianus is actually threatened in parts of its true native range in Italy. So the Iberian population, though not native, represents a significant chunk of the global population.
So managing it in Spain becomes important for the species' global survival.
Potentially, yes. And that requires complex management, coordinating with Italy, understanding its functional role in Iberian streams now. The management response is driven entirely by its current conservation value and ecological function, and has basically nothing to do with its non-native origin status anymore.
Fascinating. Okay, the case study also lets the authors pick apart why that graduated terminology, like Lemoyne and Spenning's 10 steps, doesn't really work in practice. What about the species brought in to replace the crashing Italian crayfish?
Ah, yes, the North American signal crayfish, Passifasticus lineasculus. This was introduced in the 1970s, precisely because the Italian one was disappearing. Under that graduated framework, you might call this a substitute introduction.
Because it was ecologically similar, meant to fill the same niche?
Right. They thought they were doing something sensible, maintaining an ecological function. Based on its supposed functional nativeness doing a similar job, the introduction was justified.
And we know how that story ended.
Utter disaster. The signal crayfish turned out to be a primary carrier of the crayfish plague that was wiping out A. fulcianus and other European crayfish. Plus, it's highly invasive itself, causing huge ecological damage across Europe.
So the substitution based on function completely backfired.
Massively. It shows the danger of using fuzzy, function-based labels derived from nativeness to justify management actions like introductions. Origin and function are not the same thing.
Okay, what about other types, like the red swamp crayfish, Procambers clarkii, brought in for aquaculture?
P. clarkii is another classic, introduced maybe 50 years ago for commercial purposes. Initially, under a gradient system, you might have labeled it a surrogate introduction, brought in for a specific human use of function.
Yeah.
But now, its impacts are so well documented and severe, it's aggressive, alters habitats, carries disease, scores very high on EICAT, that it's clearly seen as an invasive introduction. The authors use this to show how impact knowledge evolves. The management priority shifts dramatically over time as we learn more. But crucially, its status as non-native remains unchanged from day one. If the status itself changed with our perception of impact, you'd have legal chaos.
Right, the definition would keep shifting.
Oh.
And the last example they used to critique the gradient approach involves species where we just don't know the impact initially.
Yeah.
Like those Australian crayfish Chirax destructor.
Yeah, a couple of Australian species turned up. At the time of introduction, their potential ecological effects in Iberia were largely unknown. Under a graduated terminology, you might label these neutral introductions.
Okay, sounds harmless enough.
That's the problem. Calling them neutral implies that maybe no specific management action is needed right away. But this flies in the face of best practice in invasion management. The widely accepted principle, drawing from Simberloff and others, is rapid response. Act early when eradication or containment is still feasible, especially for species whose impacts are uncertain but potentially high.
So you can't wait until it gets a high EICAT score.
Exactly. Prevention and early detection rapid response, EDR strategies, rely on knowing the clear binary fact. This species is not native, it doesn't belong here, therefore it represents an inherent risk that needs addressing proactively, even with incomplete impact data. The binary status triggers the precautionary principle.
This case study really ties it all together beautifully. The status discovery was binary. The subsequent management reality is messy and non-binary. How did the authors summarize the actual management needed for these different crayfish?
They have a great table 1 in the paper, showing the contrast. For the widespread high-impact invaders like P. clarkii red swamp and P. lineus signal, the management goal is pragmatic. Local control where needed, eradication if you get a lucky chance in an isolated spot, and containment to stop further spread.
Okay. What about ones that aren't really established?
For species that are equally non-native, but are maybe absent now, or were eradicated or never really took hold, like a Stachys noble crayfish or Pisan angulus, the management is simple. Prevention. Keep them out. Tight biosecurity.
And for the Italian one, A. falcissianus.
For the Italian one, despite being non-native, the management is now conservation. Protect remaining populations, potentially coordinate with Italy. So you see, all of them share the same binary status non-native, but the required management actions are completely different, ranging from prevention to conservation to aggressive control, all based on their current impact, risk, and socio-ecological context.
Okay. Wrapping things up in our final section, let's think about the wider implications for policy and society, and also the limits the authors acknowledged in their paper. What's the big policy takeaway?
I think the biggest one is the need for clarity in communication. Policymakers, stakeholders, the public, they need concepts that are relatively straightforward and defensible to build laws and allocate resources effectively.
Yeah, trying to write a law based on a 10-step gradient of nativeness sounds like a nightmare.
Exactly. When the scientific community itself seems confused or keeps changing definitions, mixing up origin with impact, it creates instability. It hinders getting clear messages across and building consensus for action. Courchamp and others pointed this out back in 2017.
It's easier to get support, politically and financially, to manage a clearly defined non-native species posing a high risk than something vague like a long-term resident alien with moderate functional integration.
Absolutely. That binary status provides essential conceptual leverage. But, and this is just as important, the authors constantly remind us that the management itself has to grapple with the huge complexity of the human dimension. Meaning things like social acceptance of control measures, economic costs and benefits, local traditions, cultural values attached to certain species. Shackleton and colleagues really emphasized this in 2019. Real-world invasion management is as much about sociology and economics as it is about ecology. And those human factors make a simple binary management response totally impossible most of the time.
You can't just impose a purely ecological solution if it ignores how people live and what they value.
Precisely. So binary status for clarity, non-binary management acknowledging human complexity.
Now, about those limitations, the authors were quite specific about what they weren't trying to tackle in this paper, right?
Yes, they made a deliberate choice. They stated clearly that they were focusing purely on the ecological and biogeographical aspects of defining nativeness. They intentionally avoided wading into the deeper, often very heated, ethical and philosophical debates.
Like the arguments that the whole concept of native versus alien is inherently problematic, maybe even xenophobic.
Exactly. They acknowledged those critiques exist, but sidestepped them to keep the focus tight on improving scientific terminology for ecological understanding and practical management. It was a strategic narrowing of scope to make their specific point about binary status versus non-binary management more clearly.
A tactical move to advance the scientific clarity without getting bogged down in the broader, more value-laden debates. Okay, so if their argument holds nativeness is binary, manage the gradient, what are the key things researchers should focus on next?
Two main paths forward, I think. First, we need a real push to solve those cryptogenic cases. More research using genetics, historical ecology, stable isotopes, whatever tools we have to definitively figure out the native versus non-native ranges for species where we're currently unsure.
Like the Iberian crayfish study did. More detective work.
Exactly. The answer to uncertainty isn't to throw out the concept of status. It's to do the hard scientific work to resolve the uncertainty.
And the second research direction.
That's on the management side. We need continued refinement and better application of those non-binary impact assessment tools, making ICAT, SACAT, ICAT plus A, and similar frameworks even more robust, more quantitative, better able to handle uncertainty, and crucially, better at integrating those complex socioeconomic trade-offs. We need sharper tools to measure the gradient accurately.
So this deep dive really highlights a fascinating core tension, almost a paradox in invasion science, doesn't it?
It really does.
The main thesis boils down to this: the species' origin story, how it got here relative to human actions. That needs to be kept simple, clean, binary, yes or no. That gives us the stable foundation for describing patterns.
Right. It answers the how did it arrive question.
Right. The species' current story, its function, its impact, its risk profile right now, that's inherently complex, dynamic, continuous, non-binary. And assessing that gradient using tools like EICAT tells us what we actually need to do about it.
Precisely. It answers the what should we do now question.
Yeah.
And you absolutely need both parts of the simple status and complex assessment working together but kept distinct for effective science and management.
Okay, let's leave our listeners with a final thought to chew on, circling back to that Italian crayfish in Iberia, Ostropotomobius fulcesianus.
The paradox case.
Exactly. So we now know it's definitely non-native to Iberia, but it's endangered in its true home range, Italy. And after 500 years, it's become functionally integrated, perhaps even important, in those Iberian ecosystems. So here's the question: where does our ultimate conservation responsibility lie?
It's a tough one.
If a population is globally endangered, does its non-native status in one particular place automatically disqualify it from conservation efforts there, even if that place is now a major refuge for it? Does the binary historical fact of nativeness always trump the urgent, functional goal of preventing a global extinction?
It really forces you to think about what the ultimate goal of conservation is. Is it restoring some idealized historical baseline based on origin? Or is it maintaining biodiversity and ecosystem function for the future, potentially using all the pieces available, regardless of their arrival date? The answer probably isn't simple.
Definitely something to ponder. Thanks so much for unpacking all that complexity for us today.
My pleasure. It's a critical discussion to have.